Hey guys, I'm going to give you a lesson on 7.3. Going to start getting into some series and learning about convergence and divergence tests. Okay, so when we start this, we're going to be talking about convergent and divergent. Okay, so if you think about that series, divergent, what is different about that girl? She is going off on her own path instead of converging with what everybody else is doing, okay? So converging means it will converge down to one number, and divergent means it goes off and doesn't come together, so there's not a limit, okay? So we're going to learn geometric series, which is actually going to be the geometric series test of convergence or divergence. And then we're going to learn the nth term test, which is going to be NTT, like this, the nth term test. So in this unit, in Unit 7, we're going to learn a whole bunch of different tests. I think there's about 10 or 11 of them. And so these are the first two that we're going to learn today, okay? So I talked about this yesterday, that a sequence is an ordered list of numbers, and we can figure out how to find the next number, figuring out that pattern, okay? In this lesson, we're going to do series. So the key word here is series, and that means the sum of numbers. Now, if you remember from Math 3 Honors, we learned that this little E-shaped dude is actually a summation signal. So if I have a sum like this means I'm adding terms together, okay? So anytime you have a summation symbol, this is called a sigma. The technical term is called a sigma, not an E dude, actually. So if you call that a sigma, that's going to mean that you're adding terms together. So in this example, it's saying an infinite series. So that means there's an infinity at the top. Can be represented as the sum is the first term plus the second term plus the third term plus the nth term, plus it goes on forever, so I have to continue my plus ... This notation right here is very important. Okay, it's really important that you get your, you know exactly where your plus signs go and where your ... go. Okay, so we're going to talk about two different types of series. So here we have example 1. What happens as more and more terms of a series like this? So it's n equals 0. So you got to be careful here. Does it start at 1 or does it start at 0? Okay. So n equals 0 to infinity. What's going to happen as I add more and more terms? So they've already listed the first 4 terms for you. Looking at this pattern 1 plus 3 plus 5 plus 7, what do you think the next term would be? It's going to go to, hopefully you're noticing that we're adding 2 in between every time. So 9, and then 11, and then 13, and that is just going to keep getting bigger and bigger and bigger, right? So when this happens, the series is called divergence. So what that means is the sum of the terms gets larger. Okay, so as I add one term to the next, I'm going to get a bigger and bigger number. Okay, so if I add the 1 plus the 3, I get 4. And then if I add 4 plus 5, I get 9. And then 9 plus 7 is 16. And I'm going to keep adding more and bigger numbers. And so that sum is just going to get bigger and bigger and bigger, and it's going to go forever, right? So it's going to be a divergent series. Okay, series. Remember I talked about the difference yesterday between a sequence where we're just looking at is each term getting smaller, or a series where we look at the sum of the terms getting smaller and smaller. Okay, so that's why we've got this summation or this sigma notation. Okay, so on example 2, we're saying what happens as more and more terms get added to this. Okay, so if I'm doing this one, if I plug a 1 in, I get 3 over 10. If I plug a 2 in, I get 3 over 10 squared. If I plug a 3 in, I get 3 over 100 squared. Okay, and what you're noticing is that this is just going to be 10, 100, 1,000. It's just going to keep getting bigger and bigger and bigger on the bottom in terms of the zeros. But there's a 3 on top, so I have to look at my decimal of 3, and then it goes to another 3, and then it goes to another 3, and then it goes, because we're going to the hundredths place and the thousandths place. So this is actually approaching 1/3. Okay? So it approaches 1/3. So I'm going to say, because this approaches a single number, then it's a convergent geometric series. Okay? Now, convergent means the sum of the terms. So this is a convergent series. Again, a series is the sum of the terms. So as I add more and more terms together, the sum of the terms gets smaller and approaches a finite number. Okay, so it's going to approach and get to a number that is going to get closer and closer to that number, but never touch that number. But I can come up with a number. Okay, so hopefully you can see the difference between convergent and divergent. Now, the first series that we learn is called geometric. Okay, I talked to you about this yesterday. We said the nth term of a geometric series was a times r to the n minus 1. Okay, in this one, they're going to do a times r to the n, but this starts at 0. Okay, so just notice that if I have an n equals 1 here, then this is n minus 1. So this would be the same thing, just depending on where you start at the bottom. So you always need to pay attention to where you're starting at the bottom. Okay? So this is the general form of a geometric series. The general form. Okay. Now, what we need to know is that if the common ratio, so remember how we get the common ratio? Think about it for a minute, see if you remember. How do we get that common ratio? We divide the next term by the previous term to get r, okay? So if the common ratio, the number you're multiplying by, is greater than 1, the series diverges. If it is less than 1, it converges. Okay, so this is your first test. This is called the geometric series test. It's actually probably the easiest one, because all you have to do is remember that r greater than or equal to 1 diverges. R less than 1 converges. Okay, this is in a geometric series. Not a sequence, a series. We're adding the terms. Okay, so if I want to figure out what it converges to, I have to figure out the sum, and the sum of a geometric series is a over 1 minus r. A is just the first term, and then we divide by 1 minus the common ratio. And that will tell you what the limit is going to be of a geometric series. Okay? So you can rearrange these formulas. So even though it has a 3 and then 2 to the n, I'm trying to get it into this form. We're always trying to get it into this form or this form, okay, the geometric form. So if I did this, I could do the 3 right here, and then 1/2 to the n. Okay, so this is the same as this because 1 to the end still stays 1. So I can put the 1/2 all the way to the end. So now I know that this is A and this is R. Okay, so now we can figure out R. So this is the notation that you, when it says determine if it converges or diverges. Okay, so you say R equals, and you actually do the absolute value of R is 1/2. Okay, which is less than 1. So 1/2 is less than 1. Okay, so that means it converges by the geometric series test. So it converges by GST because I found out that R was less than 1. That's my test right there. I have to show this step every single time. You have to show how you know something and then state what it happened. So because R was less than 1, then it converges. Okay, now this says find the sum. So if it does converge, there's a sum. So my sum formula is A1, so 3 over 1 minus R, in this case, a half. So 3 over 1/2 is 6. Okay, so the sum would be 6. So this is going to converge to 6. As I add the terms together, add the terms together, add the terms together, it's going to approach 6 and never pass it. Okay, this one, absolute value of R equals 3/2. Okay, 3/2 is greater than 1 because that's 1.5. So it diverges by GST. Here's my statement of why it happens, and here's what happens. So I'm never just going to say it diverges. I'm always going to say by. Diverges by, converges by. Okay, every single time we have to say that. Okay, so on this one, we have, when you figure this one out, you have to look at, it starts at 1. These ones started at 0. This one starts at 1. Okay, so if I put in my first term, if I put a 1 in here, I would have 4 times negative 1/2. So my first term is negative 2. Okay, and then if I did it again, if I plugged a 2 in, then I would have 4 times negative 1/2 squared, which is 1/4, times 4 is 1. Okay, I just need those two because all I need to figure out is what is R. Okay, so R equals 1 divided by negative 2, so negative 1/2. We're actually going to do the absolute value of R equals absolute value of 1/2, and that is less than 1. Okay, so it is less than 1, so it is going to converge by GST. Okay, and now we need to find the sum. So it's very helpful that we found this because we found our first term is negative 2. Our first term is not 4. Okay, because the n equals 1, not 0. So our first term is negative 2, and we divide that by 1 minus R. Okay, add those together. Negative 2 divided by 3/2 is negative 4/3. And that converges. So that's your first test, geometric series test. So if I were you, I would start a paper on a separate paper and write down convergence and divergence test. And this is your first one, geometric series. Okay. Now, let's do one more example before we get into the next test. Okay. So this says find the fraction form of the repeating decimal of 0.08. So if I think about this, 0.08, this is the tens place, this is the hundredths place. So this is 8 over 100. Okay. And then if I did it again, I would have a 0.08, 0.08, right? And that would be the 10,000ths place, because it goes tens, hundreds, thousands, 10,000. So this would be 8 over 10,000. Okay, so if that's going to be my terms, like this, then I have to figure out what is A1. So A1 is A over 100, and the common ratio, if I divide this by this, what do you get? Or basically, 8 over 100 is multiplying by what to get to 8 over 10,000? So the 8 is staying 8, so the top is a 1, and then the bottom is 100, and the bottom here is 10,000. So I've added 2 extra zeros, so that's going to be 100. Okay, so if I multiply 8 over 100 times 1 over 100, I would get 8 over 10,000. And then if I multiplied 8 over 10,000 times 1 over 100 again, I would add 2 more zeros on, and we would get 1 million. Okay, and that will just keep following that same pattern. So R, this says find the fraction form of the repeating decimal. Okay, so let's find what that sum is going to be. So A1 is 8 over 100, and then 1 minus R. Okay, so 1 minus 1 over 100, and we're going to end up getting 8 over 99. Okay, and I believe you did learn this back in when you first learning decimals and stuff, you learned how to do the repeating decimals with the 99 on the bottom. But that's the reason why it works, to see how it kind of came full circle of things that we learned so long ago. Okay, let's do our last test for convergence or divergence. And this is called the nth term test. So NTT for divergence. NTT will not work for convergence. Okay, you can never say it converges by NTT. That just isn't a thing. All right, so let's talk about the difference here. This is kind of what I was stressing to you yesterday about the difference of a sequence or a series. So the series is less simple. So a series is more complicated than a sequence. So my sequence is 1 plus 1 over n. As that approaches infinity, this is going to be 0, and my limit's going to be 1. So this converges to 1. Okay, the sequence converges to 1. So sequence is like our horizontal asymptote. Okay, the series is not a horizontal asymptote. This is the summation. And so if I figured out 1 plus 1 over n, this is going to be 2, this is going to be 1.5, this is going to be 1.3. I'm adding a whole 1 plus some change to the end of every single sum. So it does not converge, it keeps going. So the nth term is like if I went on forever and ever and ever and ever, the nth term is your last term, basically. So if you're doing the nth term test for divergence, all you have to prove is that the limit is not 0. Okay? If the limit of an is not 0, then it will diverge. If you do get a limit of 0, then it's just inconclusive and you have to use a different test. We don't know other tests right now, but there are several other tests. So if you can't use nth term tests, then you would use a different test to prove convergence. You can't just say that because it goes to 0, it is convergent. There has to be other things that apply there. Okay, so basically, if I'm looking for this, I'm looking at, is the limit as n approaches infinity 0? So is the horizontal asymptote 0, or is it going to approach 0? Is it slow over fast? Okay, so looking at this one, the power n factorial and n factorial is the same. Okay, so let me show you how to do your notation. Okay, so I'm going to say the limit of this is 1/2. Okay, I already messed it up. I need to write my limit. I'm sorry. The limit as n approaches infinity equals 1/2. Okay, because I'm just looking at that horizontal asymptote. What is the horizontal asymptote of this? It's not an e, it's not a sum anymore. Now I'm just looking at just this. So that horizontal asymptote is 1/2, which is not 0. That's all I have to show, is that this is not 0. So then I say it diverges by the nth term test, NTT. So I have to show this step, and I have to show this step. Really important, remember it will never converge by NTT. Okay, all we're doing is going to show that it doesn't equal 0, so it diverges. If it does equal 0, it's inconclusive and you don't know. Okay, all right, so that is going to be 7.3, and then let me know if you have any questions. Okay.